Welcome to this hands-on guide on building real-world generative AI products with Python. Today, we're going beyond theory and diving straight into applied data science. While many discussions focus on high-level concepts, this video will show you exactly how to bring those ideas to life using powerful latest LLM, Llama 3.2 Vision 11B model. Together, we'll walk through creating an automated system for extracting KYC details, where you can simply upload a PAN card and instantly extract the essential details. This isn't just another video about what AI can do. Instead, this is about how you can do it yourself. By the end of this tutorial, you'll have taken your first steps into creating your own generative AI product, giving you an edge over 90% of people who are still only talking about AI. So, if you're ready to get your hands dirty with code, let's start building. Alright, let's get started with the first steps. To build this KYC automation, open Colab. We'll need the right tools in our environment. One key library we'll use is Groq. So let's go ahead and install it. This command will install Groq, setting us up to work efficiently with the model. Once that's done, we'll dive into configuring our LLM for real-world use. Let's move to the next crucial step, setting up our API key. I've stored my key securely in an api.txt file so we can load it without exposing it directly in the code. Key pro tip: never hard-code sensitive keys in your scripts. Always keep them separate in secure files. If you don't have a Groq API key yet, just head over to console.groq.com/keys. Log in for free, and create your own API key. Now, Groq will have the authorization it needs without exposing sensitive information in our scripts. With this, we're all set to start working with our LLM and building our KYC tool. You can use the API in your environment like this for test purposes only. Let's keep going. Let's jump into using Llama 3.2 Vision with an online image to see it in action. First, we'll connect to the model and send an online image URL along with a text prompt, so the model can analyze the content and give us insights. This code gives you a direct way to interact with Llama 3.2 Vision, which can interpret and describe visual content. The model goes on to interpret the structure as possibly a building or monument, highlighting its grand, complex design. This kind of rich description is thanks to Llama 3.2 Vision's ability to not only recognize shapes and patterns but to infer contextual details. This output demonstrates how the model analyzes visual elements in an image, which is exactly what we need for our KYC automation to interpret and extract relevant details from documents like ID cards. In the next steps, we'll apply similar techniques to real-world documents, making it functional and tailored for our KYC process. Now, let's see how we can work with local images. Specifically for a real PAN card, we'll first encode the image into a base 64 string so that we can send it to the model for analysis. This response showcases the model's ability to recognize key elements within the image, such as the names, birth date, and the issuing authority, essential details that we need for KYC processing. This demonstrates how we can automate the extraction of relevant details from a PAN card. Next, we'll extend our functionality to process multiple local images at once. This allows us to automate the extraction of relevant details from several documents efficiently. Here's the code to do just that. In this output, we see the model successfully extracting two names, one date, and one alphanumeric string from each document, allowing us to pull out relevant details efficiently. By handling multiple images, we can quickly process a batch of documents, significantly speeding up the KYC verification process. If you followed along this far, congratulations! You've already positioned yourself ahead of 90% of the folks out there by leveraging Llama 3.2 Vision. Take a moment to feel proud of what you've accomplished so far. Give yourself a huge shout out. But remember, this is just the beginning. To truly excel and stand out, you need to go beyond the basics and start building real applications. That's why we're going to create a Flask app using Llama 3.2 Vision, all for free. If you haven't subscribed to my channel by now, it is the perfect time to do so. Your support will keep this content coming and helps us build a community of innovators eager to harness the power of AI. Thank you for being here. And let's dive right back in to create our first general AI app together. Let's make this happen. Now that we've set the stage for building our Flask app, the first step is to upload our folder containing the necessary templates. Let's unzip the folder and get everything in place. Once the folder is extracted, we need to change the current working directory to access our templates easily. We'll set the path to our new directory and change the working directory accordingly. With this code, we ensure that our current working directory is now set to the pan folder. This allows us to access all the files and templates we'll need as we continue building our Flask application. Now that we're ready, let's dive into creating our app structure. To showcase your amazing capabilities to friends and family, we'll create a public URL using Ngrok. This will allow anyone to access your Flask app from anywhere as long as your terminal is running. First, we need to install the necessary packages. Next, we'll read our Ngrok token from a file. Make sure you've already saved your Ngrok token in a text file called ngrok.txt. Here's how to read it in your code. This is different from Groq API. This token is crucial for authenticating your Ngrok session and allowing you to create that public URL. Once you've got this set up, you'll be ready to share your work with others. Let's proceed to establish that connection and launch our app. In this section, we'll set up our Flask application to process the uploaded images using the Llama 3.2 vision model. This will allow us to extract relevant details from a pan card. 1. Encoding images. The encode_image function reads an image from the specified path and encodes it in base64 format. 2. Home route. The index route renders the homepage of our application. 3. Image processing route. The process_image route handles the image upload and processing. It checks if an image has been uploaded, saves it, and encodes it. The encoded image is then sent to the Llama model with a specific prompt to extract the names, date, and pan card number. If the extraction is successful, it returns the data as a JSON response. 4. Public URL. The app uses Ngrok to create a public URL, allowing anyone to access your Flask application. This setup will enable you to demonstrate your ability to process images and extract useful information, showcasing the power of general AI in practical applications. Let's dive deeper into the front end and make sure our HTML template can handle the image uploads efficiently. All the codes will be uploaded on my GitHub. Please check it out. Thank you for following along. If you found this content helpful, please give it a like, leave a comment with your thoughts, and don't forget to subscribe for more tutorials. Together, we can build amazing general AI applications for free. Your support helps me create more valuable content.